Welcome to Trikana Skill, your lifetime career partner. Trikana is a pioneer and trailblazer in the field of civil engineering and construction training, seeking to bridge the gap between engineering studies and the construction industry. Flexural strength of concrete. Aim: to determine the flexural strength of concrete. Flexure: the action of bending or curving is called flexure. Flexural strength. Flexural strength is the maximum resistance of a material in bending. This is typically applicable for structural elements whose behavior can be reflected by beams. Flexural strength is expressed in terms of modulus of rupture in megapascals or pascals. The flexure strength is commonly used in the design of rigid pavements. Apparatus.
Testing machine. Beam molds of standard size 15 by 15 by 70 centimeters. Weights and weighing devices. Tools and containers for mixing ore. Concrete mixer. Tampering rod, 16 mm in diameter and 600 mm length. Procedure for flexural strength of concrete. Sampling of materials. Samples of aggregates for each batch of concrete shall be of the desired grading and shall be in an air-dried condition. The cement samples, on arrival at the laboratory, shall be thoroughly mixed dry either by hand or in a suitable mixer in such a manner as to ensure the greatest possible blending and uniformity in the material. Proportioning: the proportions of the materials, including water, in concrete mixes used for determining the suitability of the materials available. Weighing: the quantities of cement, each size of aggregate, and water for each batch shall be determined by weight, to an accuracy of 0.1% of the total weight of the batch. Mixing concrete: the concrete shall be mixed by hand, or preferably, in a laboratory batch mixer, in such a manner as to avoid loss of water or other materials. Mold: the standard size of mold shall be 15 by 15 by 70 centimeters. Alternatively, if the largest nominal size of the aggregate does not exceed 19 mm, specimens of size 10 by 10 by 50 cm may be used. Compacting: pour the concrete into the mold in 3 layers, each approximately 1/3 the volume of the mold, and rod each layer with 25 strokes of the tamping rod. Uniformly distribute the strokes over the cross-section of each layer. Curing: the test specimens shall be stored in a place, free from vibration, in moist air of at least 90% relative humidity and at a temperature of 27 degrees plus or minus 2 degrees Celsius for 24 hours plus or minus 1/2 hour from the time of addition of water to the dry ingredients, and place the cubes in water tank for 7 and 28 days. Placing the specimen in the testing machine. The bearing surfaces of the supporting and loading rollers shall be wiped clean, and any loose sand or other material removed from the surfaces of the specimen where they are to make contact with the rollers. The specimen shall then be placed in the machine in such a manner that the load shall be applied to the uppermost surface as cast in the mold, along 2 lines spaced 20.0 or 13.3 cm apart. The axis of the specimen shall be carefully aligned with the axis of the loading device. The load shall be applied without shock and increasing continuously at a rate such that the extreme fiber stress increases at approximately 7 kg per square centimeter per minute, that is, at a rate of loading of 400 kg per minute for the 15.0 cm specimens and at a rate of 180 kg per minute for the 10.0 cm specimens. The load shall be increased until the specimen fails, and the maximum load applied to the specimen during the test shall be recorded. The appearance of the fractured faces of concrete and any unusual features in the type of failure shall be noted.
Calculation: the flexural strength of the specimen shall be expressed as the modulus of rupture Fb. When it is greater than 20.0 cm for 15.0 cm specimen, or greater than 13.3 cm for a 10.0 cm specimen.
Fb equals P into L, divided by A into D square.
When it is less than 20.0 centimeters but greater than 17.0 centimeters for 15.0 centimeters specimen, or less than 13.3 centimeters but greater than 11.0 centimeters for a 10.0 centimeters specimen. F equals 3p into a divided by b into d square. Observation. After preparing beams and placing them for curing, calculate the flexure strength by performing test for each beam for 7 days and 28 days and repeat the test for another 2 beams and find the average flexural strength and note down the values as shown in tabular column. Result. Flexural strength is about 12 to 20% of compressive strength.
Thank you for your time. If you have any queries, do not hesitate to contact us.